Hello, good day, and welcome to Inspiring of Lab 2 ik1064. We're giving UPF 7 and 8. Question 7. Describe what parametric tests are. Parametric tests are tests that assume underlying statistic distribution in the data. Therefore, several conditions of validity must be met so that the result of parametric tests are reliable. While non-parametric tests do not rely on any distribution, they can be thus applied even if parametric conditions of validity are not met. Examples of parametric tests and non-parametric tests are: for parametric test, one sample t-test, two sample t-test, one way ANOVA, factorial deal with one factor. Non-parametric tests, we have one sample sign, one sample recons, Manning-Whitney test, Friedman test, and mention rules of thumb and advantages and disadvantages. Well, the rule of thumb for parametric test is that all the informations must be in place, must be researched for a good parametric test to be used or reliable. And the advantages of parametric tests are more secure and reliable and stable, but they are harder to do, while non-parametric tests are less secure but they are easier to do. So those are both the advantages and disadvantages of non-parametric and parametric tests. Question 4. Chi-square goodness fitness test. We're given this assignment. People's emotions or personalities were divided into 4 different colors: red, blue, white, and yellow. And we have the results for the analyst. So because they had a result of red comprises of 25% of the population, blue 35, white 20, and yellow 20. And question 1 is: formulate your null hypothesis of H0 and HA based on the problem above. So my null hypothesis was that for H0, all the colors will have a balanced ratio. That means they'll be uniform together. There'll be a uniform distribution. While for my HAs, that they'll have different ratio. They'll be non-uniform. That means red might be greater than blue, blue might be greater than white, white might be greater than yellow. Now, if we take our information that we got and put said information in R, and in R we can now analyze and make use of R to get our information that we need. So let's go to our question. So what are the observed values? If you're going to our observed values or observed frequency are 97, 103, 55, and 45. And our expected values or expected relative frequency are, if we go back, I've done so much. If we go back and we run it, our expected frequency is supposed to be 75 for yellow, for red, 105 for blue, 60 for yellow, 60 for white. Why? Because we had a probability of 25, 35, 20, and 20% for each colors. So, and the final question was motivate whether H0 should be rejected or not. And the answer to that is yes, H0 should be rejected since the p-value is less than alpha. H0 should be rejected. So let's go in and see our p-value. If we run this, we get a p-value. If we run this one, put probability, run, put p dot pro, run that. we see our p-value is less than alpha, which our alpha is 0.05, so we can see it's less than alpha. And if we do our t-test result, we get the expected values again, as we said before. So the null h0 should be rejected because it is less than alpha, and the statistical method of color does not fit the observation, because our observation was that we have a balance ratio in everywhere. For example, now let's say we don't have the probability and we remove the probability there and remove that. We just have the observed frequency. If we still run it, if we still run this, we can see that our p-value now is greater than alpha. Actually, it's no more less than alpha again. So, and our alpha is 0.05. Thank you for all, and this is my recording. Thanks.